Hello everyone, welcome back to my channel Learn with Simran. In this video, we are diving deep into the world of statistics to understand three fundamental concepts: mean, median, and mode. Understanding these measures of central tendency is important for analyzing data effectively. Towards the end of the video, we will also discuss how these measures of central tendencies helps to decide the type of skewness. So let's not delay it further and get the learning started. Let us start with the mean. The mean or the arithmetic average is probably the most commonly used measure of central tendency. You calculate it by summing all the data points and dividing by the number of points. This makes it a great measure when all the values in your dataset are similar and no extreme outliers exist. For example, imagine you're trying to calculate the average revenue of a company over 5 years. If the revenue in each year is somewhat similar, the mean will give you a good indication of the company's overall performance. Let us see how to calculate mean for a dataset of 5 records. First, we will sum all the records and divide by the total number of records present in our dataset. This will give you the mean. Now let us see how to calculate the mean using the Python library NumPy. We will start by importing the library NumPy and passing it using numpy.mean of the data to calculate the mean. Similarly, you can do with the statistics library. Now let us discuss the use case for mean. When your data is symmetrical and there are not any extreme values, the mean is the best measure. For instance, calculating the average height of adults in a population typically follows a normal distribution. The mean is widely used in finance, especially for calculating the average returns over time. For instance, when you want to compute the average stock price or the average revenue of a company across several years, the mean works well. In manufacturing, the mean helps access the average quality of products. For example, you can calculate the average weight of items in a production line, which is crucial to maintaining product consistency. Now, let us see the limitations of mean. One of the main downsides of the mean is that it is highly sensitive to outliers. Extreme values, whether very high or low, can significantly skew the results. For example, if you are calculating the average salary in a company and a few executives earn millions, the mean salary could give a misleading picture of the typical employee's earnings. Now let us talk about the median. The median is the middle value when you arrange all the data points in ascending or descending order. Unlike the mean, the median is not affected by outliers, making it a better option for datasets with a skewed distribution. For example, when looking at house prices in a city, there may be a few luxury homes that cost millions of dollars. These extreme prices can distort the mean, but the median gives a better sense of what a typical house costs. Let us see how to calculate the median. Example 1 carries odd number of data points. In a data set, first arrange all the data points in ascending or descending order and then pick the middle value as median. Now, if you have even number of data points, what to do? Arrange the data points in ascending or descending order first and then pick two values from the middle and divide by 2. This will give you the median value. Now let us see how to calculate using Python. Similar to the calculation in mean, we calculate the median also. Using NumPy, we can calculate the median using numpy.median of data, and using statistics, we can calculate it by statistics.median of the data. Let us see some use cases for the median. When data is skewed either positively or negatively, the median is a more accurate measure. It avoids being influenced by extreme values. For example, in real estate, the median house price is often used instead of the mean because a few luxury homes can distort the mean. Median is widely used when analyzing income or wealth data. Since income distributions tend to be right skewed, with a few people earning very high salaries, the median gives a better representation of what a typical person earns. That's why we often hear about median household income instead of average income. In survey data, particularly when using Likert scales, for example, 1 to 5, where 1 strongly disagree and 5 strongly agree, the median is often used to summarize central opinions. For instance, in customer satisfaction surveys, the median score can give a clear picture of a typical customer sentiment. Let us see the limitations of the median. The median only takes into account the middle value or the average of two middle values, ignoring the rest of the dataset. This can be a drawback if the dataset has multiple peaks, which is multimodal distribution. Finally, let us look at the mode. The mode is the value that appears most frequently in your dataset. Unlike the mean and median, which are used primarily for numerical data, the mode is often useful when dealing with categorical data. For instance, if you are running a retail business, the mode can help you identify the most commonly sold product or the most popular shoe size. Knowing the mode helps you understand what's the popular or frequent in your dataset. Let us see how to calculate the mode. The step 1 includes list all the values in the dataset. Second step is to identify the values that occur the most frequently. Let us see how we calculate the mode using Python. Using library statistics, we can calculate it by statistics.mode of the data. And from scipy, import stats and calculate the mode by scipy.stats.mode of the data. This handles multimodal data. Let us see the use case for mode. The mode is especially useful for categorical data where the data points fall into categories or groups. For example, if you are conducting a survey asking people for their favorite color and most people choose blue, then mode of your dataset is blue. In retail, the mode can identify the most frequently purchased product or size. This can help business understand consumer behavior and manage inventory more effectively. When your dataset has more than one mode, it means there are multiple peaks or frequent values. For example, if you are analyzing the ages of people in a community, you might find two common age groups such as young adults and elderly individuals, indicating a bimodal distribution. Let us see the limitations of mode. A dataset can have more than one mode or no mode at all if no values repeat. This can make the interpretation tricky. In smaller datasets, the mode might not provide much useful information, especially if no value repeats frequently. To sum it all up, mean is great for normally distributed data but can be distorted by outliers. Median is best for skewed data or datasets with outliers because it is not affected by extreme values. Whereas mode is useful for categorical data and when you want to find the most frequent value. Knowing when to use each of these measures is crucial to making accurate interpretations of your data. Whether you are analyzing sales, financial performance, or customer feedback, the right measure of central tendency can help you uncover meaningful insights. Before we wrap up, let us talk about the skewness, which is a measure of how asymmetrical your data distribution is. Skewness shows us whether the data points are concentrated more to one side of the mean or if they are evenly distributed. A perfectly normal distribution will have a skewness of 0, meaning it is symmetrical, and the mean, median, and mode will all be equal. However, most real-world data is not perfectly symmetrical, and skewness helps us understand the direction of the symmetry. Let us discuss the types of skewness. Negative skewed data or left skewed. In a negatively skewed distribution, the tail is longer on the left side. This happens when there are few extremely low values in the dataset, pulling the mean down. As a result, the mean is less than the median and the median is less than the mode. For example, imagine you are analyzing the retirement age in a population, but there are few early retirees. The mean retirement age will be dragged down, making it lower than the median. In a positively skewed distribution, the tail is longer on the right side. This occurs when there are few extremely high values that pull the mean upwards. As a result, the mean is greater than the median and the median is greater than the mode. For example, income data is often positively skewed. A few very wealthy individuals earning significantly more than the majority can raise the mean, but the median and mode remain lower. Whereas in zero skewness, symmetrical or normal distribution, the mean, median and mode will be equal. You can calculate and visualize skewness in Python using libraries like SciPy and Matplotlib. Here's a simple example. Let us see why skewness matters. Skewness helps you understand the distribution of your data and whether the mean is a reliable measure of central tendency. In highly skewed data, you may want to rely more on the median than the mean. In fields like finance, marketing, or product development, skewness can indicate whether the majority of your data points lie and whether there are a few extreme values affecting your analysis. To conclude, we can say understanding skewness is essential because it helps us decide which measures of central tendency to use. In symmetrical distribution, the mean, median, and mode are roughly the same, so the mean is a good choice. In negative distributions or left skew distribution, the median is often a better choice as the mean is pulled downward by the low values. Skewed or positive distributions, again the median is more reliable since the mean is affected by high values. By recognizing skewness, you can make more accurate interpretations of your data and choose the most appropriate statistical tools.
In case if you have found this video helpful, do like, share and subscribe to my channel Learn with Simran. Thank you so much for watching. Keep learning. Bye bye.